Hey, welcome back to the lecture. And in the previous lecture, you understood about the host and bootloader communication. We will discuss more on this in the implementation part also. Don't worry about that. And in this lecture, let's see what are the formats of the commands that we send from the host to the bootloader. Here is a command packet format for the command bootloader get version. So the host sends this command in order to get the bootloader version. So remember that in our implementation, in every command packet, the first byte will be the length to follow field, and the second field, that is the second byte, will be the command code of that respective command that is sent by the host to the bootloader. And our project will also use CRC code of 4 bytes in order to help bootloader to check the integrity of the bytes received from the host. So in this particular command, that is bl get version, the total bytes of the packet will be 6 bytes. So 4 plus 1 plus 1 plus 4, right? And the length to follow field will contain the value 5, and the command code will be 0x51 for this command, and the reply sent by the bootloader for this command will be 1 byte. That will be the bootloader version number. Now let's see another example. This is the bootloader get help command. The goal of this command to extract all the supported command codes from the bootloader. I suggest you to refer to this document in order to understand what each command does. All right. And in this particular command, the total bytes of the packet will be again 6, and the length to follow field will contain the value 5, and the command code will be 0x52, and bootloader reply will be all the supported command codes. We will see more on this when we implement this code in our implementation lectures. And here is another command, get the chip identification number of the microcontroller. Again, the length to follow field will contain the value 5, and total bytes of the packet will be 6 bytes, and bootloader reply will be 2 bytes for this particular command. So that is actually 2 bytes of microcontroller chip identification number. Now let's move forward, and here is another command. So this command format is little different. This command is bootloader go to address. All right, now let's explore that command here. Bootloader go to address. This command is used to jump bootloader to specified address. So host uses this command in order to instruct the bootloader to jump to specified memory address. So that memory address will be sent by the host in this field, memory address. So the format is the first 2 bytes will be reserved for length to follow and command code, and the third field will be memory address of 4 bytes mentioned by the host, and again the last 4 bytes will be the CRC. So once bootloader receives this command, it will jump to the memory specified by the host. So here the third field will be base memory address, that is 4 byte base address to jump, and the total byte now will be 4 plus 4 8 plus 2, that is 10, and the length to follow will contain the value 9, and the bootloader reply will be status, whether it is success or failure. The failure happens if bootloader detects that the given address is completely invalid, because the bootloader jumps to only those memory locations for which it is allowed. So if host mentions any invalid address, then the bootloader will simply reply saying it's an invalid address in the status field. So we'll see more on this as we make a progress. Don't worry about that. And now this is the command packet format to execute the bootloader flash erase command. And the host uses this command in order to instruct the bootloader to erase a particular sector or range of specified sectors. And the command format is very simple. The first two fields are as before, and the third field will be sector number. Alright, so in my microcontroller there are 7 sectors. Sorry, there are 8 sectors from 0 to 7. So host will mention which sector needs to be erased in this field. So the only allowed values are this much, 0 to 7, and how many sectors host wants to erase starting from the sector number over here. So that host can mention here. So the range is from 0 to 7. So for example, here if I mention something like 3 and 2, then host wants to erase sectors 3 and 4. So because number of sectors to erase is 2, isn't it? So that's why starting from 3, bootloader erases 2 sectors, 3 and 4. Alright, and the status will be what exactly is the status of that flash erase command, whether it is a success or failure. Alright, so that status code will be returned to the host. And the next command is memory write. Now this is really important command because we use this command in order to program the binary into the microcontroller flash memory. And there are 3 extra fields here. One is the base memory address. That means the host tells the bootloader start writing from this base memory address. And the payload length, that means how many bytes the host wants to write. So that is mentioned in the payload length, and then this field is the payload, that is streams of bytes which the host wants to write onto the flash or RAM memory of the microcontroller. So you can use this command in order to write to any allowed memory address. Alright, so it need not be only flash. It can be RAM, SRAM1 or SRAM2 or any other allowed memories. Okay, so here the payload length field is 1 byte, isn't it? So that means the maximum value of this field will be 255, isn't it? So that's why the maximum bytes you can send in a payload field is 255 bytes, isn't it? Alright, so here is a description. Base memory address, that is, it's a 4-byte base address from which bootloader should start writing into the memory, and payload length is number of bytes to write, and payload, of course, it's a stream of bytes to write. Fine, so that's the format of the BL memwrite command. Now let's move forward. Alright, so the next command is bootloader memread. That means a memory read command, and this command is actually used to read the contents of the memory back into the host. Okay, so you can instruct the bootloader to read some bytes from the memory address given in this field, and you have to mention how many bytes you want to read in this field so that the bootloader can read those amounts of memory contents, and it can send it back to the host, and then host can write that into some text file or something to recreate the bin file or something like that. Okay, so this is not a much useful command, but you can implement this command as a part of your bootloader development. And this command I have not implemented in this project, so I have left this as an exercise for the students, and if you are interested you can implement this. So here the base memory address means 4-byte base address from which data has to be read, and length is number of bytes to read, and the status will be the reply from the bootloader will be status plus length number of bytes. So if status is 0, then it's a success. If status field is 1, then it's a failure. So if status field is 1, then this is ignored, and if the status field is 0, that means it's a success, and this will contain length number of bytes. Okay, great. Now let's move to the next command, that is bootloader enable read write protect. So this is very important command. This command is a very simple command, so which is used to put read and write protection on different sectors of the flash memory. So here in this field, it's a 1 byte field. Here you have to mention the sector details, or you have to encode the sector details. So sector numbers are encoded in 8 bits. For example, 0th bit is sector 0, so like that. So 7th bit is sector 7. So if that bit is 1, then it means protection is needed, and if any bit is 0, then no protection, so protection is not required. And protection mode indicates whether you want to put a write protection or a read write protection on those sectors which are encoded in the sector details field. Alright, so status will be the reply from the bootloader, and if the status is 0, it means success, and if the status is non-zero, then it's a failure. Great. So use this command if you want to put read and write protections onto the different sectors. Now let's move to the next command, bootloader disable read write protect. So this command is very simple. It doesn't have any arguments. Okay, so this actually disables active protection on all the sectors. So it will resumes the status of the sectors to its default state. So it actually disables all the active protections. And again, the status will be the reply from the bootloader, only 1 byte, so non-zero means it's a failure, and if the status is 0, that means it's a successful execution of the command. Alright, so now the next command is bootloader read sector status. So this is a very simple command. As you can see, it doesn't have any arguments, and this command is actually used to read back the protection status of different sectors of the user flash memory. So don't worry if you are not understanding anything right now. As we make a progress, we are going to explore various things about the protection status of different sectors of the flash memory, how to change them, how to configure them, and how to read them. So all these things we are going to explore by referring to the reference manual of the microcontroller, and at that time it will be clear for you to implement this command. And this command, when executed, bootloader reply will be 2 bytes, okay, which consist of the protection status of all the different sectors of the user flash memory. Great. So now this command is actually not implemented. It is left as an exercise for the students to complete, and don't worry, so you will have enough knowledge and enough hints in order to implement this command when we explore the different protection status of the flash memory. Great. So with that note, I would like to end this video, and from the next lecture, let's get started with the implementation.